Hi everybody. In this video, we're going to look at how we can set up a model for two units that are in direct proportion, or they vary directly. So when two things are in direct proportion, it means that they change together in the same way. So if one doubles, the other doubles. And we're going to use something called the constant of proportionality, which we use the symbol K for. So I'll show you how we use this as we progress through the questions. In example 1, we're told that h and g are in direct proportion. We need to use the constant of proportionality to model the relationship. So we start by writing the statement that h is directly proportional to g. So we're saying that this h will vary as g varies. So this tells you that they're in direct proportion, but it doesn't describe the rate at which they change together. So our model is h is equal to k times g. And this k describes how they change together, the rate at which they change. And we can find this k by substituting in a pair of h and g. So therefore, the h, which is 20, this 20 here, is equal to k multiplied by g, this g. And now we can work out k by dividing both sides by the 8. So k will be 20 divided by 8. K will be 2.5. So our model is h is 2.5, which is this value of k, multiplied by g. And now we can use this model to work out this value of h and this value of g. So when g equals 10, h will be 2.5 multiplied by that value of g, so multiplied by 10. So h will be 25. And when h equals 14, we'll substitute that into here. So 14 will equal 2.5 times g. So therefore, g will be 14 divided by the 2.5. And this is 5.6. In question B, we're told that m varies directly with n. Now, varies directly is the same as being in direct proportion. So do you want to work out the constant of proportionality k that describes the rate at which they both change? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. We know that m varies directly or is in direct proportional to n. So therefore, the model will be m is equal to k times n. Again, this k describes the rate at which they change together. So we can work out the k. We'll substitute 9 for the m and 15 for the n. So 9 will equal k multiplied by 15. So therefore, k will equal 9 divided by 15. We can simplify that fraction and we get 3/5. So our model is that m is 3/5 of n. Now it's easier when you're dealing with fractions and algebra to write this as m is equal to 3n over 5. It just means it's easier to rearrange this equation. Now do you want to try and use this model to work out the value of m and the value of n? Okay, so if n equals 20, then m will be 3 lots of 20 divided by 5, and 60 divided by 5 is 12. And if m is 24, this will be 3n over 5. We'll multiply both sides by the 5, so we get 120 will equal 3n. Divide both sides by the 3, so n will equal 40. How did you get on with that? Let's try some more examples. So in example 2 and 3, we're going to look at how we can apply this to a real-life situation. So in example 2, the cost of fuel, C, and the number of litres purchased, L, are in direct proportion. So you can understand that as you buy more litres, you pay more money. We need to find the missing values. So the first thing we need to do is we need to define our model. So we say that the cost is directly proportional to the number of litres. So C will equal KL. Again, this K describes the rate at which it changes. So this is like the price of a litre. We can work out K. We know that when C is £32.40, this will be K multiplied by the L, which is 18. So K will be 32.4 divided by the 18, which we can simplify to make 9/5. So our model is that C is 9L over 5. And when L equals 29, the cost will be 9 lots of that 29. We're substituting L back into our model, and we're dividing it by 5. And this works out to be 52.2. So using pounds and pence, and when C equals £61.20, we'll substitute this back into our model here. So we get 61.2 will be 9L over 5. We'll move this 5 over to this side. So we get 306 will equal 9L. Divide both sides by 9, and L will equal 34. Do you want to give question 3 a go? Try to define your model by working out K, and use your model to work out the distance for 42 hours. You can pause the video and come back when you're ready. Okay, so we know time is proportional to distance. So time will equal K times D. We can work out K when T equals 30. The distance will be 135. So K will be the 30 divided by the 135, which simplifies to make 2/9. So our model is that T is equal to 2D over 9. And now to work out the distance, we'll substitute in 42 into our model. So 42 will be 2D over 9. We'll multiply both sides by 9. We get 378 will equal 2D. So therefore, D will be 378 divided by 2, which is 189 kilometers. Let's try 2 more examples. So in example 4, we're asked if U varies directly with T, and we need to give our reason for our answer. So if U and T are in direct proportion, if they vary directly, then the value of K will be constant for each of these pairs. So we need to begin by defining our model. So U is proportional to T. So U will equal KT. So from our first pair, the value of U is 5.3 and T is 1. So K will equal 5.3. And we can check this with our second pair. When U equals 31.8, does this equal the K multiplied by the T? And 31.8 does equal 6 times 5.3. And for our final pair, does 75.9 equal 5.3 lots of 15? And yes, it does. So we can say, therefore, as K is constant, U is directly proportional to T. Do you want to have a go with question 5? So we'll say that Y is directly proportional to X, so therefore Y will equal KX. From our first pair, when Y is 4.5, this will be K multiplied by 3, so K will equal 1.5. From our second pair, when Y is 12, does this equal 1.5 times the 8? And yes, it does. And from a third pair, does 12.6 equal 1.5 lots of 10.5? Well, 1.5 times 10.5 is 15.75, which is not equal to a 12.6. So we can say, therefore, as k is not a constant, y does not vary directly with x. Well, thank you very much for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.